free training provided by the HVAC School podcast is made possible because of the generous support from our sponsors, Testo, RectorSeal, and Carrier. Quick fun fact. The MeasureQuick app, now available on iTunes and Android, is awesome. If you've listened to this podcast, for any amount of time, you've heard Jim Bergman come on the podcast, and Jim is actually the founder of MeasureQuick, as well as a lot of other things. And Jim, actually many moons ago, worked with Testo. Testo is the first hardware that works directly with the MeasureQuick app. And you may say, what's so special about MeasureQuick? Well, I could explain it to you. I could tell you all about measuring delivered capacity, measuring sensible versus latent, giving you diagnostic probability of different faults, as well as explaining those faults and training you on those issues just in time, on a just-in-time basis, which is what we're all about here at HVAC School. And the Testo Smart Probes and the Testo Smart Probes app are some of the first smart tools to work with the MeasureQuick app. And so you may ask yourself, well, why wouldn't they do it? Well, I'll tell you why most manufacturers, or I shouldn't say most, but why many manufacturers don't want to work with a third-party app, a third-party software like MeasureQuick, even though it is an industry-changing software. It's because it's competitive with the softwares that they've already built, right? I mean, they've already made these applications, and while they may not be as full-featured as what Jim's built with MeasureQuick, it's hard to kind of bite that bullet and say we're going to work with a third party. But Testo has shown their commitment to the trade in the same way that they spend time and effort and money in sponsoring the HVAC School podcast. They're taking a risk and partnering with Jim in order to make this something that's a really good thing for the industry, because Testo makes absolutely fantastic hardware. They always have. I mean, that's the reputation, is making really good hardware. But by allowing for this partnership with Jim and the MeasureQuick app, they're showing their commitment to the technical side of the software, that they're going to work with the industry-leading software in this area. I think it's really cool. I think it says a lot about Testo. Check out the Testo Smart Probes kit and all of the Testo smart tools. You can get like the 115i is their clamp. They have a manometer, they have a vane anemometer, they have a hot wire anemometer, they have even the 770-3 multimeter works with the Testo Smart Probes app, which then in turn works with MeasureQuick. Thank you to Testo for your commitment to the business, and thank you for working with the MeasureQuick app. And if you want to buy some Testo tools, you can do that very easily by going to TruTech Tools, TruTechTools.com. Use the coupon code GetSchooled for 8% off. If you want to try out the MeasureQuick app, just go to MeasureQuick.com/download now. That's MeasureQuick.com/download now.
Meet ZoomLock, the 10-second flame-free refrigerant fitting from Parker. Reduce labor costs by 60% with no brazing, no flame, and no fire spotter. Discover how ZoomLock can help you be more efficient and productive. Visit ZoomLock.com for more information.
This is the guy who used to buy turtle wax with his own money and wax condensers on every maintenance. Brian Orr.
One of the partnerships I'm really excited about with HVAC School is with Parker Sporlan. And this is because ever since I started in the trade, ever since I set foot in trade school, I remember seeing Parker Sporlan posters up on the wall, and I would work on Parker Sporlan valves and Parker Sporlan filter dryers. I wanted to have them on today and talk with you about filter dryers, filter dryer technology, both suction filter dryers, liquid line filter dryers, biflow dryers. Parker Sporlan has a really nice bulletin. It's sort of an application guide, an overall overview of filter dryers, how their use, how they work, their selection. If you can just Google this, just look up Sporlan 40-10. That's the name of the guide. The name of the bulletin is Sporlan 40-10. And a lot of what we talk about today is going to be kind of circling around what's in that bulletin. But here we go. We have Chris Reeves from Parker Sporlan. All right, so today on the podcast, I have Chris Reeves, not Christopher Reeve, although I don't know. Do you ever wear a cape and fly around the city, around St. Louis?
I try not to, but it was pretty convenient having a built-in nickname growing up. There's worse nicknames to have, I'm sure.
Okay, so you don't have like a big Superman tattoo on your chest or anything that we should know about?
No.
All right. So Chris is the product manager for am I saying this right? This is the contaminants division of Parker Sporlan?
For the contaminant control products, so primarily that's our filter dryers and the products that support that contamination control, anything that are system protectors, and then even some of the cleaners and other accessories that we have here within the business.
I reached out to Sporlan and I wanted to talk about filter dryers because it's an interesting thing because they're such a simple component. I mean, they have no moving parts. At least they shouldn't have moving parts. That would be bad if they did. But there is a lot of misunderstanding in the trade, or at least a lot of, maybe not misunderstanding, but a lot of disagreement in the trade about some different elements of it. So I wanted to kind of set the groundwork of filter dryers before we got into some specific applications. Before I do that, if you wouldn't mind introducing yourself and just tell us a little bit about your journey in the industry and how you got to where you are now.
Sure. My background in schooling is in chemical engineering, and I've been in engineering design and research and development roles since I graduated from college. And I started in the refrigeration industry with Sporlan about 8 years ago, and I've worked gradually in various roles, but primarily in the design and development of sealed model filter dryers. All filter dryers I've had some experience touching the designs with, but mostly on the sealed model filter dryers and suction filters. I have that design kind of background within the contaminant control or filter dryer aspect, and now I'm more on the product management side, where I'm responsible for making sure that that clear communication about contaminant control products is provided to not just our customers, but then the end users, the contractors that are installing these, and making sure that everybody's informed about proper uses of filter dryers.
Very good. And so first thing I want to do is I want to confess that I'm a cheater pumpkin eater. I am looking right now in front of me. So if you hear pages turning, I'm literally looking at Parker Sporlan Bulletin 40-10, okay, which is a Bible, as far as I'm concerned, of filter dryer knowledge. And so I'm going to kind of use this to guide myself through the process. And for everybody, all of you listening out there, you can follow along with this.
That's good to do because I have learned very early that it's impossible to memorize everything and know all the facts right off the top of your head. So I refer to that bulletin myself just to make sure that I'm keeping track of the proper way to use filter dryers, to select them, because there's a lot of different applications out there that you can go to this bulletin and get that proper knowledge.
So there's a lot of general information here about applications and how the catch-all series, in the first part especially, how it works and the different components and all that, which is very interesting, good information to have. But you really want to refer to this bulletin regularly when you're selecting filter dryers. So whether it's a suction dryer, liquid line dryer, or heat pump biflow dryer, no matter what it is, you use this to select the appropriate dryer for the appropriate application. So I just want to put that out there. Those of you who are listening, if you're sitting at home or whatever, you may want to pull up this bulletin as you listen to this because it may make it a little easier to follow. And then also, if you're in the field, this is something you should have saved on your phone or your laptop or whatever to refer to regularly. Or if you want to go old school like I am right now, just print it out and keep it on your truck in a binder or something. I'm all about resources. Knowing things is fine and great, but knowing where to find them is even finer and greater. What are some of the things that filter dryers are there to do in the first place? What is the purpose of a filter dryer? What is it there to do?
All right, well, there's three main aspects to a filter dryer. I'll start with the first one in the name. It's a filter. So that's definitely one of the primary purposes of a filter dryer is to filter out all those solid debris and contaminants that can then go on and damage any components or malfunction certain components downstream of that. That was the reason Sporlan came out with a filter dryer back in the 1940s to begin with, was that there was valves coming back that had some sort of defect or issue. These valves are not working properly. And as Sporlan tried to troubleshoot what the cause of failure was, there wasn't really nothing wrong with the valve, but there was debris. There was something that was preventing the valve from operating properly. So that was the necessity as a mother invention. We had to invent something to protect these expansion valves and valves that needed the tight tolerances between the pin and the port to control flow properly. They needed something to protect those devices from this dirt and debris and from the sludge. So the filter dryer was invented out of that necessity years and years ago. And that's still one of the primary functions, is to, if anything solid, whether it's debris from brazing, copper oxides, other things from the brazing process, whether it's from just dirt that's in a line set from dragging it through a work site, whether it's from any other sources, rust on insides of steel components. Hopefully you don't have that, but if you do, we want to have a way of protecting those valves. So the filtering of the solid debris is probably the first aspect. The second word in the name is the dryer. That would be the next thing I would talk about, is the ability to capture and hold water from the rest of the refrigerant system. So once the system is installed, it's an enclosed system, and there's not any escape or entrance of fluid into that system. So once it's in there, it's got to maintain its balance, its chemistry for the life of the system, or until you break it open for some servicing. So the goal of that dryer is to sequester and capture as much of that moisture and keep the moisture content at a really low relative amount. We're talking in the parts per million, to keep that system dry and functioning properly. And then the third aspect would be to remove acids from the system. In the same way it's capturing and holding moisture, we want to capture and hold acids. And what that does, as moisture starts to interact with polyester lubricants or other system fluids, it has a tendency to break those down into acids or other byproducts. And the faster you can capture those and keep those out of the rest of the system, the more likely that your system is to maintain its healthy status indefinitely into the future. So I would say those three: filtering the solid contaminants, the moisture removal, and then the acid removal. Those are the main purposes of installing a filter dryer in your system.
This, I think, is a common misconception that a lot of, especially newer technicians, might have. They have a sense that the filter dryer, whether it be a suction dryer or a liquid dryer, can filter out gases. So non-condensables, nitrogen, air, those sorts of things. And that just isn't the case, right?
It's typically not. If it is, it's at a very low level. So I wouldn't count on a filter dryer or any of the desiccants that are involved in that to remove any of those non-condensables. That's correct.
The next thing to add here is that while a filter dryer does have the dryer in it, the actual desiccants to capture moisture, that is not the primary means that we want to remove moisture in a system. So performing a proper evacuation and pulling it down to the proper micron levels and performing a decay test to ensure that you have a tight and dry system is step one, and the filter dryer is only there as a backup. So those out there who would say, who needs to pull a vacuum if you just put your filter dryers in, that's not a correct way of thinking, correct?
While it is substantial, the amount of moisture that filter dryers can hold is limited. So you want to keep your systems as dry as possible to prevent lubricant and refrigerant breakdown. And in order to keep them as dry as possible, you're going to limit the amount of loading that you're intentionally putting on that filter dryer. So having that moisture level low to begin with is very important. I agree.
We think in terms of both internal and external contaminants. So you have external contaminants, which would be like if you didn't fill nitrogen while you were brazing, and so you had carbon flakes inside the system, or if you got some dirt in the system when you were assembling it, heaven forbid, or moisture that entered the system when you initially were starting the equipment up. But then there's also internal contaminants that can occur over time with the breakdown of the windings, varnish or sludge that can occur, or acids that can occur because of heat and the breakdown of the refrigerant oils. So if you have compressors that are overheating, or just the natural wear and tear that happens inside of moving components, you can get contaminants inside of the system in the same way that when you're running a car engine, you have a filter and the oil, and those contaminants are coming primarily from inside the engine itself that have to do with the breakdown of the oil through heat and through the mechanical components actually giving off some of their material. So I think sometimes we think in terms of, well, and I've heard people say this, well, if you do everything right in the first place, then there's no need for a filter dryer. And that's an oversimplification as well.
I agree. I think it's an oversimplification. Even if you're confident that you do everything perfectly as an installation or through the installation process, there's a lot of other opportunities for things to not go perfectly that are not within the realm of control of somebody doing the install. You mentioned the motor windings. Different defects within any of the components can have some sort of release of contaminants, whether it's from residues that can be extracted by the refrigerants, which make really good solvents, or whether it's just from the age and deterioration over time of certain components. The industry does a very good job, better than most, I would say, of making sure that new materials introduced are very compatible and have long lifespans once they are put into a system. But there's always that opportunity for whether it's a material change or with a material being obsoleted and a new one being put in, or other additives being added to the system. There's infinite combinations of things that can take place outside of your control that could cause issues, and you want to be protected against those if that's the case.
Exactly. But the two things that you do want to control when you're setting up a system, when you're servicing a system that can have a great impact on contaminants inside of a system, are You want to make sure that you keep everything that doesn't belong in the system out at the beginning, and that includes moisture, solid contaminants. Anything that doesn't belong in there shouldn't be added, or the manufacturers consistently say oil and refrigerant. That's what you want to have. And so you want to make sure that the only thing in that system when you first start it up is oil and refrigerant. But then the next thing is that during the operation of that system, you want to make sure that you have proper temperature control. And specifically, we're talking about in the head of your compressor. That's the hottest point in the entire system. And so if your compressor head is hotter than it should be, and there's lots of different things that can cause that, that I go into in other articles and podcasts, but you want to make sure that that temperature is controlled. And also, you want to make sure that lubrication is maintained, both through the proper return of lubricant with your piping and all that design, and then also with ensuring that you're not having a flooded condition either on start or during running where liquid refrigerant is residing in the compressor, resulting in lubrication loss inside the compressor. Because those are things, either overheating or loss of proper lubrication, that result in these unwanted materials showing up inside the system.
Correct. There's a couple things that come up regularly that surprise me, but I guess I'm also not surprised with the fact that they come up. But a couple things to remind ourselves continuously is that the filter dryer and then your POE lubricants that you typically use also, both of those, they want to attract moisture. So it's important to keep those, isolated and sealed right up until the time where you're ready to install those. Any amount of time where the lubricant is left exposed, it can be absorbing moisture from the air. The same with the filter dryer. Once you open that up and allow air, the outside air, ambient air, to access that, it's going to try to scavenge moisture from the air itself. So you want to keep those isolated and sealed as long as you can, right up to the point where you're ready to install those.
If you've had a line dryer exposed to atmosphere for more than a couple minutes, then I wouldn't even use it. One of my technicians the other day, and those of you who listen to the podcast may know Bert, he was being funny, and I don't even know what happened here because he knows better than this, but he was taking a restricted dryer, an old restricted dryer, and showing that it was restricted by blowing through it, and then comparing it to a brand new dryer. So he's got this brand new dryer and he's blowing through it with his mouth. I'm like, dude, you just ruined that dryer. I mean, seriously. Let alone opening it to atmosphere. Now you're blowing your breath through it. So anyway, don't do that. Don't be like Bert in that area.
I saw a filter dryer core for sale on eBay that was open and exposed and still like new, but I wouldn't recommend installing one that's been open to the atmosphere.
Yeah, let alone if something could have actually gotten into it from a solid standpoint, but just the moisture itself, it kind of ruins the dryer part of the filter dryer.
Right.
All right, so a couple other things I want to talk about are placement and removal. So where do you suggest, specifically speaking of liquid line filter dryers now, where do you suggest that liquid line dryers be positioned?
The best place to install these, we're going to recommend installing them as close to your expansion device as possible. So usually that means inside on your liquid line right prior to the line going into your evaporator there. So that's going to do a couple things. One, it keeps the unit out of the outside atmosphere, so you have some corrosion benefits there because it's inside, but also it just takes all that line space between where you would have installed it outside and where it's installed prior to the expansion device, and takes all of that line set and protects it with the filter dryer as well. So while they can be installed outside, there's nothing that really prevents them from being installed outside. It's just a little safer. It's a recommended practice to install them inside as close to that expansion device as you can.
Yeah, and that's something that we practice. I've gotten some flack over talking about this in the past because the topic that comes up a lot is, well, a lot of manufacturers put it inside the condensing unit, so if they put it there, why is it wrong for us to put it there? And I don't think it is necessarily wrong, but my response to that would be, manufacturers are going to put it inside their appliance. They want to make sure that it gets installed, so they're going to put it inside the condenser, but that still doesn't mean that that's the ideal location.
Yeah, it's interesting because you'll see some that are installed in the condensing unit inside that compartment on the outside there, and you'll see others that are shipped loose with the condensing unit, and it leaves it up to the installer to then put that in. And it just kind of goes back and forth in terms of what the likelihood of somebody not installing one that's shipped loose versus having that added security of knowing that, hey, this is on our condensing unit and is there regardless of whether the installer chooses to or not install it.
Condensate overflow switches are very much under-considered in both maintenance situations service calls, and in installations. Technicians, they get used to installing them one particular way, and then they want to apply that rule to every single switch that they run into. And different applications require different types of switches, even in the Unified Mechanical Code. So James Bowman and I talk about that a couple episodes back if you want to hear about that. But RectorSeal is a leader when it comes to condensate overflow switches. They have the Safe T switch, they have the Easy Trap, and they also have the AquaGuard lines, all under RectorSeal, and they all make different products that serve different purposes. They have products that have the trap already installed that you can clear out, and you can see the entire trap. Even with the safety switch, the SS1, which is a switch that we've used for years, they came out with a clear-bodied version, so you can actually see what's in the switch, which is pretty cool. We use a lot of the SS2s, a lot of the SS3 pan switches. They just have a really wide, broad line. And when you look at AquaGuard has some really neat, innovative products. They have one float switch that you can actually unthread the cap from the bottom in order to get the water out and check the float, which is a nice design. So there's a lot of different products that you can get through RectorSeal in the condensate switch category. But the one thing that I want you to think about is next time you open up one, so say you open up a safety switch, the SS1, read the manual, because you'll find some things that you maybe didn't know, like, for example, that the float is adjustable. You can actually adjust the height of the float to suit the application, and that alone makes a big difference in application to application, situation to situation. And so whether you're mounting it horizontal, whether you're mounting it vertical, whether you're mounting it in the primary drain or the secondary drain, whether you have pitch on it or not, these are all things that are going to help you decide which one of these products you choose. So check out the full line of products at RectorSeal. You can go to rectorseal.com to find out more. That is the Easy Trap, Safety Switch, and AquaGuard. The best practice is anytime a system's been open to atmosphere at all, it's best to go ahead and replace that liquid line filter dryer. Most people in the industry know that. But when you are removing it, this is something that I've brought up a lot to technicians, you really shouldn't be heating that up in order to remove it. And so what I'm asking basically is, when you remove it, we suggest that you cut them out, because if you heat them an old line dryer, then you run the risk of releasing that moisture back into the system. Because as you heat it, in some cases, if you get it too hot, it can tend to reactivate some of that and actually release some of that moisture back into the system.
So removing a filter dryer, it's definitely cleaner to cut it out. As you add heat in, heat is one of the ways that you reactivate or drive off some of the water that it has captured. So anything, whether it's just driving off moisture or whether it's actively overheating to the point of damaging internals and having other debris, it's much safer to cut the filter dryer out than it is to torch it out.
As far as installing the filter dryers, and this is true of suction and liquid line filter dryers, you also want to be pretty careful with the amount of heat or how hot you get the dryer, correct?
That is correct. You want to avoid overheating when you can. We take care to make sure that filter dryers, as they're being installed, that they're not overly sensitive to excess heat. But it's definitely a good idea to get the heat on, high heat, for a limited amount of time and get the joint made as quickly as possible. There are internal components that can be damaged, whether it's a suction line, a biflow, or a standard liquid line filter dryer. There's polyester filter pads that do some of the filtering at the outlet there. So if you add a lot of extra heat, you do run the risk of damaging not only that filter pad or fiberglass, whatever the filtering media is, you do run the risk of damaging that and adding additional debris to your system.
Got it. And so you're talking specifically with that polyester filter pad, that's actually on the outlet of the filter dryer. And so if you're taking that outlet stub and you're just getting it blue blazes hot, you do run the risk of damaging that, because while it is, heat resistant, it still can melt if you apply way too much heat, correct?
Right.
Got it. So a general good practice would be just wrap it in a rag or use some sort of a heat trap. There's a lot of different products out in the market that can help you protect. But if you could put just a nice wet rag on the body of the valve, that's going to help keep the valve cool, because most of the conductance is going to be in that shell. So if you keep the heat off the shell, that's going to greatly reduce the chances that you damage the line dryer. Besides the fact that if you burn the paint and you're in an exposed location, then that can potentially lead to rust and corrosion.
Correct. In addition to wet rag, a lot of times you'll be flowing a small amount of nitrogen. That'll help dissipate that heat as well as you're doing that brazing. Besides a wet rag, like you said, there are a lot of products out there that can also help block or dissipate that heat around a joint and protect valves and filter dryers as you're installing them.
Yep, definitely flowing nitrogen. Flowing nitrogen is something you certainly need to be doing. And that while that does help dissipate some heat, it also helps you from contaminating that brand new dryer with carbon flakes right off the very beginning, which is also not a desired thing. So what is the construction of a BiFlow dryer that makes it different than a typical liquid line dryer?
So a lot of the things are going to be very similar. You're going to have the standard molded core, just like the single flow dryers have. You're going to have some sort of outlet filter, typically a polyester pad that filters on the outlet side of that. But the difference is going to be in between the fitting and those filtering devices. So you're going to have some sort of check valve built into that filter dryer that will divert all the inlet flow, whether it's coming from the left side or the right side. Is going to divert that flow by a check valve device around the outside of the core and make all of the flow, again, regardless of flow direction, all the flow is going to go from the outside of the core through the core and then out its respective outlet pad through the other side of that check valve. So it's going to basically provide that same filtering and filter drying, the moisture sequestration aspects of it. It's going to apply that whether it's in both directions. And it's not going to allow the contaminants, as you collect contaminants either on the outside of the core itself or on the filter pads on the outlet sides, it's not going to allow those to be flushed off, because in either direction, whether the flow is going forwards or reverse, the flow is always going to be going through that core and filter pad the same way.
Got it. Makes sense. All right. Another quick thing is core dryers. So I think a lot of technicians who work primarily in residential and light commercial, they don't tend to think about core dryers as an option. But there's a lot of good sense, especially if you're doing a significant retrofit or if you're dealing with a burnout, of using a replaceable core type assembly instead of a sealed core dryer, correct?
Right. If you have larger systems or if you have burnouts or other type applications where you do have a large amount of contaminants and you want to limit the amount of replacements that you do have that ability to add a replaceable core type shell, and that'll allow you to install, whether it's a cleanup style core or a standard core, high water capacity core. You can install those to decrease the amount of times you have to change that filter dryer out before the system is back to a healthy state again.
And you make a really good point. There are options out there as far as the types of dryers, both in sealed and in the core type, so that you can clean up particular conditions that exist. So let's talk a little bit about the HH series of dryers and what that means and what they're good for.
Yeah, so the HH cores, the HH style filter dryers that we have, those have an additional desiccant in addition to the molecular sieve or the activated alumina that can constitute a standard liquid line dryer. They have a third component called activated carbon or activated charcoal. It's called many different names, but it's basically there to help collect some of those varnishes and sludges and waxes, some of those debris that can be caused by a burnout. And it's there to clean up specifically those types of contaminants that may not be caught by a molecular sieve or an activated alumina.
And this is kind of what I was hoping to point out to technicians, because we can't cover all of the different exact product lines and everything. That'd make a pretty boring podcast. But just to recognize that there's a lot of options out there. And so what I see most often with technicians, especially in residential and light commercial, is they just pull off their truck what's on their truck. And they don't think about the opportunity for different types of media, or maybe using a replaceable core type dryer on a large system that they're working on instead of a sealed type filter dryer. And the main thing that I guess I want you to get out of this when you're listening to this is recognize there's different types of cores, there's different types of dryers, there's different applications, and you really want to think specifically about the particular application when you're selecting a dryer.
Right. Anytime you've had a compressor burnout and you're replacing that compressor or the condensing unit altogether, you've got a system that has the potential to have some of those residual contaminants in there. You want to make sure that you select the proper filter dryer to take those out. And for those applications, we definitely recommend having that activated carbon in addition to the other desiccants to make sure that your system is then restored to its original operating conditions after you've changed out the condensing unit or the compressor itself.
So let's talk quickly about the application of the suction line filter dryer. What is Spornland's stance on the proper applications and uses of suction line filter dryers?
Typically, you want to, again, they're not for new installations. There's really not a huge need on the new installation. There's not a need for that added pressure drop at that instance. But once you have an issue with the system, whether you're replacing a condensing unit or a compressor, you want to install that suction line dryer as close to the compressor as you can. And that's basically to protect, obviously the compressor is one of the biggest, most expensive pieces of that system. So you want to protect that new investment there. So we recommend having that as close as you can get that to the compressor so that you can protect it. But you also want to make sure that you're constantly monitoring that after you put it into that system, making sure that it's not causing a large amount of pressure drop, because the pressure drop there in that suction line does tend to hurt your system efficiency more than it would, say, in the liquid line. So you want to make sure that you're keeping your pressure drop low in your suction line, but also make sure that you've properly cleaned up that system. So you want to make sure once you install that suction line filter dryer that you're going back and you're checking the acid level in the lubricant. You want to check what the pressure drop is for other solid contaminants, and you really want to keep that, for most residential systems, try to keep that pressure drop in that suction line dryer below 3 pounds differential.
Yeah, and so with the suction dryer, you're relying on the ports across the suction dryer, which is on a suction dryer, you're generally going to have inlet and outlet ports, or at least in many cases you will. And that's a really nice thing to have to monitor that pressure drop.
Right.
Because the overall sense in the business is that you just don't ever want a suction dryer in the system. And that isn't necessarily true. It's okay to have a suction dryer in there just so long as the pressure drop is as low as it can possibly be. And like you mentioned, below 3 PSI is really where you want to be in most cases.
Right. That's the big key. Making sure that both your system chemistry is back to a stable position, and then making sure that your pressure drop is not causing undue strain on your compressor. Those two things are the most important. We understand that a lot of times it's not convenient or it's not very plausible to get back in, remove those. And while the best recommendation would be to remove it, it's not going to be detrimental to the system if you leave it in there, as long as those two things are met, that the system lubricant has a low enough acid content and that the pressure drop across that is within that reasonable limit there.
And that's where, if you're working, say, in grocery store refrigeration, suction core dryers are just a typical part of your existence, because you're dealing with all this shared refrigerant, and the cleanup is so important. And so you're going to replace your cores as you need to in order to keep your pressure drop low. And anytime you have a burnout of any sort, you're going to take pretty extreme measures to make sure that you're not contaminating every compressor in the entire rack, for example. So obviously the size of the system, it kind of tips the scale on what's more important. If you're dealing with a small residential system, you may say, all right, in this case, I'm not going to put as much effort into coming back multiple times and checking pressure drop and all of that. But whereas any acid contamination in a rack makes a big difference, that may be, a more regular consideration. In fact, that's almost a standard maintenance procedure in a lot of grocery store refrigeration type situations.
The other thing to keep in mind to help aid in that is to make sure that you size the units properly. So if you're concerned about getting back and checking it and taking it out, something you can do to help eliminate undue pressure drop is oversizing those filter dryers. Or if you're right on a selection recommendation where the system can have either a 16 cubic inch suction line dryer or a 30 cubic inch suction line dryer, for a lot of those service applications, definitely recommend going up to that next size and play that conservatively.
Yeah, because larger size means more surface area, which means you're going to have less pressure drop, even if it is catching contaminants. Now, one thing to at least consider is that if you do have pressure drop, that means that it is catching stuff. So it's doing something, and it is good to, obviously, if you have contaminants in the system, it's good to get those out. But there is no absolute rule here. In residential, the good common practice is you put the suction line dryer in for a set amount of time. Maybe it's 3 days of operation, 48 hours in that range. And then you come back and you measure the pressure drop. And in most cases, you're going to go ahead and just pull it out at that point for a mild burnout. But ultimately, when it comes to cleanup, you have to do testing to see whether or not acid is present. You have to put in filter dryers, both on the suction and liquid side, to deal with that contamination. And then ultimately, you want to put it back to as close to zero pressure drop as you possibly can for peak operation.
That's correct, yes.
There is a chart. If you go to page 35 of Bulletin 40-10, there's a chart that actually talks about maximum recommended pressure drop for both permanent installation and temporary installation, meaning meaning that I think the highest here is 8 PSI that you would ever want, even in a temporary circumstance, because beyond that, you're going to start to run some issues.
Yeah, definitely. Once you get up to that 8-pound differential there, you're really going to be causing undue strain on your compressor. It's going to be working even harder. It's going to create higher discharge temperatures. At that point, it can almost be creating additional issues just by that added heat that you're adding into the system. So even under temporary conditions, you don't want to have excessive pressure drop through that suction line filter dryer.
Absolutely. So the other thing that I want to mention here, because this comes up a lot, I don't think there's any real good answer to this, but we run into circumstances where you have systems where the filter dryer from the factory, the liquid line filter dryer, is installed in an extremely inconvenient location. I'm not going to name any names, but one of them rhymes with Schmenix heat pumps. There's a couple brands that these things are really, really hard to get to. They jam them right next to heat mode TXVs and some heat pumps, and I work in a heat pump heavy industry, so we see this all the time. And so technicians are torn. So I open a system, say, to replace an evaporator coil. So I pump down the system, I replace the evaporator coil. Do I really need to recover the entire charge and replace this factory liquid line dryer? Or do I not put in another dryer at all? Or do I put in another one and have 2 in line? Do you have any comments on that?
It's definitely recommended that you would remove the factory installed filter dryer at that point, unless you have a lot of other information on the system, which you probably don't. There's no way of knowing what that filter dryer has already captured. So there's a couple things that'll happen there. If you leave that filter dryer in, all of the solid debris, the contaminants that it's captured, and it's already creating some sort of pressure differential across that filter dryer from the debris that it's captured. Whether you reclaim the refrigerant or not, debris in that pressure drop is still going to be there. You want to actually remove those from the system, if you can. The other thing is that the moisture that it's already captured and sequestered. So once you recharge that system with clean refrigerant, that moisture is still going to be in there, and it's not going, as you add the new filter dryer in, it's actually going to try to drive that moisture level down even further, and it's going to scavenge and basically come to a new equilibrium with the moisture that's in the old filter dryer. So you definitely want to remove that filter dryer from the system.
All right. Okay. And I agree with that. There are some practical considerations that I've discussed in the past. Like, as an example, there are cases where there are a couple models where if you remove that old filter dryer, the odds that you damage the existing expansion valve are approaching 100%. And there's no space in between the filter dryer and the expansion valve. And so these are things you're just going to have to consider based on the age, condition of the device, and have that conversation probably with the customer. And in some cases, they may be the ones to make the decision about what to do, because there's added expense anytime you do these additional things. And of course, those of us who always want to do things right, we're always in this tough spot, because on one hand, we would always want to do things the perfectly best way, but we're competing against a marketplace that largely doesn't care about that. And those are the prices that our customers are comparing us to. So it's always especially in the residential market, it's always a little tricky. But it's good to know that the best thing to do is anytime you open a system up, remove any existing filter dryers, whether it be suction, liquid, and either, in the case of liquid, always replace it. And my suggestion is, if it's a factory dryer that's inside the condensing unit, my suggestion is just to go ahead and straight pipe it there and then put it near the expansion valve inside, or near the metering device inside if it's a split system, in order to protect that metering device the best possible way.
It is unfortunate that they're packaged so tightly at times, where it puts you in that bind of doing what would be best overall versus potentially causing more harm by damaging the expansion valve or other components that are packed in real tightly with it. So it is unfortunate that you're put in that situation at times.
Yeah, I mean, it happens. It's life. Chris, we've got a hard life out here in the
That's right.
HVAC field. Me sitting here in the air conditioning in my office talking about problems that other people have. It's tough. Tough to be me. All right, man. Well, I appreciate you coming on and talking about it. Is there anything that I forgot to cover as it relates to filter dryers, suction line, or liquid line?
I don't believe so. I appreciate the time, and I'm always interested in learning, because, again, I'm not out installing these every day and seeing the applications. So anytime you have questions, or see something that's abnormal, shoot them our way. You communicate with Dennis fairly regularly, so feel free to shoot those images or questions or just comments back, because we're always interested in having that feedback and understanding how our products are being used and perceived by folks in the field.
Very good. Well, thank you for your time. I appreciate you taking the time to do this. I appreciate Sporlan for doing all that you do for the industry and making a great product. So hopefully we'll get a chance to talk to you soon.
All right. Thank you very much.
Well, thanks for listening to this podcast about filter dryers. Nothing more exciting than listening about filter dryers. I mean, what's more captivating? You know, you have an earbud in and a friend walks up to you and says, "Hey, what are you listening to?" "Oh, I'm listening to HVAC School and I'm learning about filter dryers." How inspiring. But thank you for doing it. It shows that you are committed to your career. It shows that you care about the industry. And there are a handful of us out there. I think it's a growing handful. I like to believe that it's a growing handful of people who are kind of waking up to the depth and breadth of this trade. And one thing that I'm excited to be a part of is the Blue Collar Roots Network, which you can find by going to bluecollarroots.com. And what we're building at Blue Collar Roots is something that's for the HVAC trade for sure, but it's for the blue collar trades, or for, I should say, all blue collar kind of workers out there. I'm wanting to curate some of the best podcast host topics that will be interesting to the blue collar world, blue collar people who work with their hands every day. But also really looking at it from a developmental standpoint, where we want to have fun, we want to have entertainment, but we also want you to learn something every time you listen to one of our podcasts or consume some of the media that we create. So we've got some great podcasts to start with. We have the Tool Pros podcast, we have the Building HVAC Science podcast, we have HVAC Shop Talk, we have the Tradesman, we have Service Business Mastery with Tersh Blissett. And we have some others coming on. We have one coming on called Wash and Paint Academy, which is going to be, outside of the HVAC industry, talking about, pressure washing and window cleaning and painting and those sorts of things, but very, talking about the best practices in that business. We have a podcast that's about fishing. It's called the Rather Be Fishing podcast that's going to be coming out very soon. And that's kind of for the everyman who thinks about fishing while they should be working kind of thing. And so Mike Clokas is going to host that podcast. So I'm excited about these podcasts. I'm excited for what they're hopefully going to do for the blue-collar trades. I want to increase the notoriety of the blue-collar trades. I want it to be more respected than it already is. We're starting to see some of that already. Props to Mike Rowe for everything he's doing over at Mike Rowe Works. But I'm excited to see what we can do with blue-collar roots. So thank you for that. If you want to listen to any of those podcasts, I would suggest that you can start by just going to bluecollarroots.com, but you can also subscribe to all of them on iTunes or Stitcher or Google Play. Leave them reviews, subscribe to them. That would be very much appreciated if you'd be willing to do that. So by now, you know that I tell a stupid dad joke, ironically at the end of every podcast. Obviously, I don't think they're really that funny, but I was looking for one. I was trying to just make it a little more educational, right? So I wanted to tell a dad joke about the noble gases. But all the good ones are gone. All right, we'll talk next time on HVAC School.